and then addition or subtraction. So those are the orders of operation. So parentheses, exponents, then either multiplication or division, or addition and subtraction. That's the order we need to know, and then these are the steps. Over here, I'm going to write the steps, and then we'll work the problem in between. First thing you want to do is you want to write the problem. And sometimes the problem's given to you, and then the challenge is just making sure you copy it over exactly right. Sometimes it's a word problem, and you have to decide what the words are telling me in the symbols. So we'll be practicing that a little bit. The next step is to solve using the order of operations. Remember, order sets the priority. It tells you what gets done first. Solve using the order of operations, and I'm going to say one step at a time. Just do one thing at a time. Just do one parentheses or one exponent for the best, and then check your work. Again, these are hard to get a gut feel from what you think the idea is, unless it's some sort of word problem that you might have some idea of. So the best thing to do is to check your work. Solve using, and then show your work. Show what you're doing in your reasoning and your reasoning. As you're doing it, it just takes a minute to be writing it down. And so remember last week, we were saying that it's best if you think of this as an order, as a first, then next, and a finally. So it's done in this order. Of course, if you don't have one of those things, you skip a step, but it's done that way. So I have a couple of problems to try out, different ones to look at, and so I'm going to try some that have just, oh, I thought I had it already here. Oh, here we go. So if I have, here's one to try. 2 times 5 to the second power minus, when we say parentheses out loud, we say the quantity of, minus the quantity of 4 plus 1. So that's how I would read that up. I want to double check. Remember, I wrote the problem, but I'm double checking that I did really write the problem right. Okay, so 2 times 5 to the second power minus the quantity of 4 plus 1. That's if I was saying it out loud for you to write it down in symbols. That's what we would be doing. Okay?
Who already knows the answer?
You know the answer?
I do.
Do you?
Yep.
I'm always nervous with these to guess too far out to have an idea. Well, we can think about it. All right, so the first thing is parentheses. Everything else stays the same, and all I do is take care of parentheses. So 2, multiplication, 5 squared, same. The subtraction symbol stays the same, and I change the parentheses. 4 plus 1 becomes 5. And now it's just one term, so I can actually erase the parentheses. If the parentheses is around one number, I could leave it if I wanted to. Okay. Next thing is exponents. So the 2 stays the same. The multiplication stays the same. The subtract 5 stays the same. 5 to the second power. That means not 5 times 2. It means 5 times 5. Repeated multiplication. 5 times 5 is 25. Now I'm here, multiplication or division, left to right. Remember, these are both whatever I see going left to right. So as I move from left to right, I see 2 times 25. I see this multiplication problem first. So I want to do that. 2 times 25 is 50. And then I want to subtract 5. And then I add or subtract. This time I'm subtracting. There's no addition. Left to right. 50 minus 5 is 45. Mrs. Nelson, is that what you thought it was going to be?
That was the answer that I got. But that's years of experience, right? And so it's not just about getting the answer here. It's about practicing the process and creating that carrot where you have the larger algebraic expression at the top and you're coming down as you evaluate each section to a single answer. So it's all about the process.
Okay, questions? All right.
Okay. Is there, do you have one more problem?
Oh, I have another problem. Okay, so this one has got, it looks a little bit differently, and when you first see it, it's a little daunting. 22 minus the quantity of 3 squared plus 4 divided by, that whole amount divided by 12 divided by 4. There are a lot of things going on in here. So that is right out of the book here. I'm double checking. I write it down and I do double check that I've written everything down. It is really easy, especially with a problem that I'm writing down sort of out of context, out of a scenario, that I might make a mistake and skip a sign or skip a exponent.
Anything division to me is daunting because you have the top and you have the bottom and it's difficult for me to, but I think
it's time to just go, now it's time, especially when it's daunting, to be very methodical, very step by step and do piece by piece. All right, so the first thing I'm going to do is just zoom in on the parentheses. So everything else stays the same. So before I even get in on the parentheses, I'm just going to write everything else down. I'm being careful not to skip everything. I kept the denominator the same. I kept the numerator. And now I'm going to really zero in on these parentheses. And actually, I really want to do it over here, because remember that step of showing your work? I really don't want to cram it in here. I want to do it right here. I want to look at that parentheses. So if I look at this parentheses, and often is the case inside the parentheses, we have an order of operations as well. So inside the parentheses, sometimes I have more. This one I don't. But I do notice I have exponents and I have addition, so I better use this order. First thing I want to do is take care of the exponent. 3 times 3 is 9, and keep the addition. And then 9 plus 4 becomes 13. It didn't take me long to write that down here, and I'm just going to leave it here because when I'm working with all of these things, I can make mistakes, and my brain could be thinking about what's coming next. And I can make a mistake here, but later when I'm done with the problem, I can really look at it a little bit different. Okay, so now we have parentheses, we have exponents, we have multiplication and division. We still have parentheses here. And I know that sounds funny. We do still have parentheses here because these are invisible parentheses when you have the division bar. So we really do need to take care of the numerator and the denominator, and then I can do that division. That's implied. So that's why I liked this problem, but it's also a tricky one, which is why I'm glad I'm doing it with you. So I'm going to look at the numerator, and I'm going to treat the numerator and the denominator differently. So in the numerator, 22 minus 13 is 9. And then I'm just checking 9 plus 13. Yeah, that would be 22. I'm just double checking it. 12 divided by 4. 12 divided by 4 is 3. 12 divided by 4. Yeah, that's 3. 3 times 4 makes 12. Okay, now this problem just says 9 divided by 3. That's all I see, 9 divided by 3, and that is 3. What are you thinking?
And what questions do you have? What are you thinking and what questions do you have? Was there anything else that you saw in the lesson that was difficult that you would like to have Mrs. Brown model?
Were there any problems from the examples that were tricky?
Nobody's talking to me, Mrs. Brown. So
Okay, I'm looking for another something here. I'm trying to see if they had one where you had, where it was explained to you in words, because those are the
Word problems or what's in the hot questions? Let's answer one of the hot questions.
zipping back, because I was bouncing around looking there real quick. Well, there's a butterfly, but it's not the hot question. The hot ones are right expression for the area, dimensions of the figure. That one is really tangly.
Let's do something tangly since nobody has any questions.
Can I do the butterfly one just because I love butterflies?
Absolutely.
So here's what I'm going to do. I'm going to hold it up so you can read it. And it says, does it look backwards to you, or can you guys read the text perfectly fine?
We can see it.
What page is it?
It is page 256. It's the back side. So here's an example where you have a scenario, and we're going to then write an equation and solve it.
Ellen is playing a video game in which she captures butterflies. There are 3 butterflies on screen, but the number of butterflies double every minute. After 4 minutes, she was able to capture 7 of the butterflies. Okay, look for a pattern, write an expression.
All right, so write an expression of the number of butterflies after 4 minutes. So whenever I'm using a word problem, I go back. What's one more step before that is draw a picture if I can. So this is step 1/2.
Can't see that because it's on the light, but I like it.
Sorry, I'll move it.
That's good. That's beautiful.
All right, so the first thing, I'm going to draw a picture. Here's what I'm going to do. I'm going to give myself a little space. We're going to work over here. Oh my gosh, I haven't seen anybody use a squirt bottle to clean things off since my junior year in high school with the overhead projector.
Oh, I do it all the time.
In the classroom, I have like the Wi-Fi. I don't know. I like it though. He sat with the overhead projector and he would just sit there and do it. All right, so order of operations. First thing, she's playing a video game and captures butterflies. So I'm going to draw a picture. See, and this is why I don't like to do it, because it leaves my screen wet. There's some butterflies. Just want to do a quick sketch. She's saying there are 3 butterflies on screen, so I want to make sure I start with the picture. It says 3 butterflies on screen, and she's playing a video game. There are 3 butterflies on screen, but the number of butterflies doubles after a minute. So this would be for how it starts, and then as time goes by, as another minute goes by, after 1 minute goes by, I'd have 3 more butterflies because it just doubled. But I could see after another minute, I would have 6 more butterflies, and then the next minute I would have, that would double. So this just doubles. So I might write the word doubles. And sometimes I can think of a picture and sometimes I can't, but I want to make sure that it doubles after 1 minute. And then she captures 7 of the butterflies. So she's got that net. I'm going to draw a quick net down over here. And she's going to be able to capture some of the butterflies, not all of them. But inside the net, there will be 7 butterflies. 7 butterflies in the net. And I want 2, 3, 4, 5, 6, 7. She's able to capture it. All right. So I have to think about this now. She's playing a video game. There are 3 butterflies on screen. And then it wants to know what happens after 4 minutes. 3 butterflies on screen. And it doubles every minute. So it's going to double every minute. Doubling, if something's going to double, that's the second power. But it wants to know what's going to happen after 4 minutes. So is it just that I have that? No, wait a minute. No, wait a minute. It's going to double 2 times 3. That doubles 2, right?
Yes, that's what I was thinking. I would have done 2 parentheses 3, but I'm sure it doesn't matter. However you would do it. That was how I would do it.
And when we say that we have 4 of those, Or how do we do that? It doubles, but I have to think about this. Here's what I know. Okay, so I have to write an equation, but here's what I know. So I'm going to draw a picture of what would happen after 1 minute, 2 minutes, and then I'm going to use that to help me write my equation because I want to make sure I get the right expression. So after I started with 3 butterflies.
Even
And
after
after
3
1
minutes, she's only going to have 6. How's she going to get 7 butterflies? I don't know. Something about the problem I don't understand.
Okay, so after 1 minute, she has 6. When 2 minutes goes by, now she'll have 12 butterflies, right? Because the number of butterflies double each time. So we start with 3. After a minute, she's got 6. After 2 minutes, she's got 12. After 3 minutes, she'd have what?
24.
And after 4 minutes, she'd have how many?
48.
48. So I'm thinking about that. And then all we do with this capturing 7, here's the part I know. At the end, we're going to take away 7. So at the end, she's going to end up, there was 48, but she captured 7. So I know the answer is going to be 41. Now what I got to do is work back so I can make an expression. I know doubling.
So she gets it after 40, after 4 minutes, she captures 7?
After 4 minutes, she was able to capture 7 butterflies.
Okay.
And I'm going to assume that it was after 4 minutes and it wasn't like right here. So the 6 was only 5 and then doubled. I got to make some assumptions. I'm going to assume that after 4 minutes, she got the 4, didn't take some off here. So these changed. Now what I really got to think of is how do I get this expression to be 48 here? And I know I have to have something with 4 happening in there. So it doubles every minute. If I just put the 4 out here, would that help me? If I had 4 sets of that, would that help me?
Well, 4 times 2, 4 distributed on the 2 would be 8. And 4 times 3 would be 12. 8 plus 12 would be only 20.
That's not enough. And I know it's got to be 48. So I know there's something with the exponents, right? I know there's something happening there with the doubling. After 4 minutes, doubled.
What happens if you, anybody have any ideas?
Anybody's got it. I don't want to get tangled up because I got to make sure this makes 48. And I don't know that it's so much the 2 times the 3 as it's 2 times whatever it was. So here's one way I could write it. Maybe I'll write it a long way and break it up. How did I get this? This expression was 2 times 3. What did I do here? I did 6 times 2 here. How did I figure this out? I knew what it was, right? I knew whatever this was, I wanted to get. Okay, so how did I make? This 6 really came from 2 times 3, right? Because that's where the 6 came from. That went to there. And then this whole answer came over to here. So this was really made as 6 times 2. Yeah, this was made as 6 times 2, and this was made as 12 times 2. So if I look at, this is where I'm going to get the 48. 12 times 2 times 2. And now I know.
I think you need the 3.
I know, because how do I make it 3? It's 3 times 4. Okay, now I got it. Now I got it. Now I got it. Okay. I had to break it apart a little bit, but now I got what would make sense to go with the problem. She starts with 3 butterflies, and then it's multiplied by, it's doubled. It's doubled how often? It's doubled 4 times. 2 times 3 is doubled. So I start with the 3 and I double it, and I do that 4 times. And then I have the 2 and the 2.
What's 3 to the 4th power?
What's 3 to the 4th power?
And that would be way too big, right? 3 to the 4th power would be 81, right?
Yeah. Many.
That'd be too big.
This whole thing out. I have 4 of those. Oh, because this doubles 4 times. This doubles. There's something going on here because I can see that this is doubled 4 times and then I'm going to double that again and double that again. I know I can break it out here and I can write it just like that, and then I can write it as 2 to the 3rd power times 3 times 4 subtract 7. I knew I could get it from my reasoning. I was just trying to see if there was a more elegant way to explain it, that when I'm going to double it, why I would be doing that, why it would be 2 to the 3rd power.
Why would it be 2 to the 3rd power?
It worked out here to be 2 to the 3rd power because I just knew from drawing the picture, after 1 minute, I would have 6 butterflies. And then I'm doubling it, and I'm doubling it, and I'm doubling it. And all I did was do some prime factorization here.
Can you read the problem again?
I can read the problem again. I can show it up here too. Sometimes reading it is one thing and seeing it is another. So Ellen is playing a video game where she starts off with 3 butterflies, and every minute the number of butterflies doubles. And after 4 minutes, she was able to capture 7 butterflies. How many does she have left?
Okay, thank you.
So we were able to figure out how many butterflies she would have after 4 minutes just by thinking about the problem. And then I'm going to subtract the 7.
So 6 times 4. 6 times 4.
Is this right even, or did I make a mistake?
I don't know.
Okay, I'm going to
3
pull
times 3 is 24. Times 4 is going to be a lot.
I think I put that number too big. So if I make this as 3 times 4 times 2 times 2 and 3 times 2 times 2. Oh, I see. I think it should be 2 to the 4th power. Would it be 2 to the 4th power times, oops, and that looks like 24. 2 to the 4th power times 3. I think that's better, because if I take 12 and I make it 3 times 4, and then this one and this one, and then the 4 breaks up to 2 times 2, so it's 3 to the 4th power. I'm sorry, 2 to the 4th power times 3, and then I subtract 7 from that. 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 3 is 48, so that gets me the number there. And I think now as I look at it, I think from the problem, I start with 3 butterflies, and when I multiply 2 times 3, it's doubled. And I'm going to do that 4 times. So it's the 2 that's going to the 4th power because they're 4 minutes. So if I wanted to do it for 5 minutes, all I would have to do is change that 4 to a 5. If I wanted to do it for 6 minutes, it would be to the 6th power. So now that I had a reason and I couldn't see it going in, sometimes I just don't see it, but it's doubling every minute. So for 1 minute, it would be 2 to the 1st power, makes 6. For 2 minutes, that's what's doubling, it's squaring again. For 3 minutes, and 4 minutes. And now I can find a pattern. Now that I see it, you could tell me any number of minutes, and all I have to do is change the power of the 2.
So you're squaring the number of minutes, not the number of butterflies. You're multiplying the number of butterflies. I like it.
I'm using the number of minutes as the exponent, because every time I add another minute, I'm using as an exponent to 2. Multiplying by 2 means doubling. Every time I add another minute, I add another factor of 2. Another minute, another factor of 2. Every time I had another minute, I added another factor of 2. 1 minute had 1 factor of 2. 2 minutes had 2 factors of 2. 3 minutes, remember if I broke this down, it would have been 2 times 3. Now I have 3 factors of 2. Now I have 4 factors of 2. After 5 minutes, I would have 5 factors of 2 because a factor of 2 means double. Every minute, another double. So I added another factor of 2 each time.
So when it said to look for a pattern, what you did was you looked for the pattern within the factors and the factors of the time, not the number of butterflies. So I think a mistake would be to be looking at the number of butterflies, and I think that would be our tendency. But if we did that, we wouldn't come up with the right answer.
Right, so that's why drawing the picture, once I knew what the answer could be, then I could find the pattern. Sometimes I see the pattern first and then I can figure out the number. Sometimes I know what the number should be and then I look for the pattern. It's a little hard in math sometimes. Sometimes the patterns are right there and you see it, and sometimes they're not. Sometimes it takes a minute.
And math is all about patterns. And that's how we use patterns and order of operations to solve problems in the real world.